Hi guys, in this specific video we're going to look at specific examples and try to see whether they fall under the category of odd or even functions respectively. So in our first discussion we have decided that for the concept of even functions, a function f of x can be regarded as an even function if for every value of x in the domain of fx we're going to have this f negative x being represented as the function of x. And then we said that a function can be regarded as an odd function uh, if the function fx y is equals fx given as such, if for every value of x in the domain of fx, and we have f negative x represented as negative the function of x given as such. So in this specific discussion, we're going to use specific examples and try to see whether these two specific conditions for odd and even functions are going to, of course, be applicable. Therefore, that is going to assist us classify functions as either odd or even. And in this case, I'm going to use just one of the examples or two in order to illustrate the same. So I'm going to have a function which is going to be y equals x squared plus 4. And we have said that I can just give a summary of this for even, whereby f negative x is equivalent to f of x. And then I've said about the concept of odd, whereby f negative x is equivalent to negative fx given as such. So I'm going to use these two specific conditions and try to see whether this specific example that I've given on the board is either odd function or even function. So what I'm going to do then, given this one, which is going to imply the function of x, I'll try to see whether the substitution for this f negative x is going to give me the value of f of x. So therefore, I'm going to have this one represented as negative x squared plus 4. It's going to give me the value of f negative x as such, so which is equivalent to, so the square of a negative value is going to be a positive value, which is going to be x squared plus 4. And as I said, of course, this is going to still give me the value of f of x given as such. So therefore, the function y is equals x squared plus 4 is going to imply an even function. Since the negative, the value of an f negative x is equivalent to the value of f of x, therefore we're going to classify this one as an even function. So suppose we do a counter check and try to see whether this is going to give us the condition for an odd function. We're going to do a substitution whereby we're going to have that one given as the negative of x. So in trying to find the negative value of x, as we said, of course, we had said that fx is equivalent to this f negative x, which of course we had indicated from this latter discussion that is going to be equivalent to negative square of x plus 4. So therefore we have a value for this. But if we try to look at the difference between that one, we can have a negative f of x being given as negative the value of x squared plus 4, which is going to be negative x squared plus, or rather, minus 4. So if we try to look at the value of a negative fx given as such, which is going to be negative x squared minus 4, this is going to be different from this, therefore it's not going to be equivalent to this. So therefore, if you try to compare it against an odd function, this condition is not going to be obeyed for an odd function. Therefore, this particular function is not going to fall under the category of an odd function. So if you try to look at that a second case and see whether the function is either odd or even, we can have a function of y is equivalent to the cube of x minus 2x. So let's try to look at this specific example for the second one. Or rather, we can just be able to differentiate still using the two expressions for even and odd. whereby we're going to have f negative x being equivalent to a negative x cubed minus 2 into negative x given as such. So we're trying to check whether this function is even. So therefore, this is going to give us, so the cube of our negative value is going to be negative 3x given as such, 3 raised to power 3 given as such, and this is going to be positive 2x given as such. So this is going to be the value of f into negative x, which if we try to compare this one for the fx and the negative f of x for us to ascertain whether it is even, this of course is going to create a difference whereby we are going to have this one indicated as of course indicated as a positive 2x minus x cubed. So if we try to look at the value of an x cubed in this particular case for fx, it's positive, but for negative x it is going to be a negative. And the value for 2x in this specific case for a function of f of x is different from the function of f negative x, whereby we're going to see that it's going to be a positive value. So therefore, this function cannot be categorized as an even function. So let's try to do a counter check for it and see whether it's going to be an odd function. So for an odd function, it's going to be using the second specific case for negative f of x. So if this is f of x, then negative, if f of x is equivalent to x cubed minus 2x, implying negative f of x is going to be equivalent to negative into x cubed minus 2x given as such. So this is going to give us a value for negative x cubed plus 2x given as such. So let's try to see whether this is going to be the negative value of x of x is equivalent to f minus x as such. So f into x given as such is going to be equivalent to, so if we try to look at this one, this is going to be minus, so this is going to be minus x cubed minus 2 into minus x given as such. So this is going to give us the cube of a negative sign is going to give us minus x cubed, and this is going to be plus 2x given as such. So if we try to look at this and compare it with this one, so this for the value of f of x, and this for the value of negative f negative x. So the two are equivalent, and therefore we can be able to say that this specific equation for f of x is an odd function respectively. So trying to use an algebraic method, that's how we can be able to differentiate between the two. And of course we had said that there's a graphical way in which we can be able to differentiate between even and odd function by finding out that the graphs of even functions are symmetrical along the y-axis, whereas the graphs of the odd functions, of course, are symmetrical at the origin. So that's the difference between the two. And these are some of the examples we can use to differentiate between the two functions, as we had promised in our earlier video. So that is it for now, guys. Catch us in our other videos. Kindly check in our description boxes for various links which are going to assist us understand this specific concept. So that is it for now, guys. Bye. God bless you.